if you know the quadratic formula, this is like a 10-second question, right? The question is, though, do you know it? I ask my students, first thing I ask them, I give them a quiz on math, and it involves the quadratic formula, and it's 50-50. Some people get it right, some people get it wrong. And it's not even like I'm asking to give me the quadratic formula from scratch. I'm handing them a version of the quadratic formula. It's wrong, but I ask them if they think it's right or wrong, and they're just not good at it. So my advice is you probably don't know the quadratic formulas as good as you think you do. But if we do know it, right, negative b plus or minus square root of b squared minus 4ac all over 2a, then most of this kind of works out, right? The negative b, negative 5, there's no kind of weirdness there where we have double negatives. That's nice. Square root of 5 squared, 25, minus 4ac. That part's annoying. So 4, 6, negative 7. I wouldn't do that if I didn't have to. And then all over 2a, so 2 times 6 is 12. So already I can kind of see it's not going to be b, it's not going to be d. Even if we started manipulating this thing and reducing stuff, it wouldn't work out that one of those is right. And then what's the difference between a and c? Well, yeah, the 168 is plus or minus, but 25 versus 36, it's got to be a, right? And even still, if I multiplied the negative in front of the 4 to the negative 7, we'd have a positive number. So that checks this piece off. And of course, I can go to the calculator and do 4 times 6 times 7, and I bet it's 168, but I wouldn't really want to. So there you go. That works. Another possibility is if you were in any way unsure, you could use Desmos, but my advice here would you could graph this thing and get the decimals and compare decimals, but I would say just, I don't know, maybe this is stupid of me, but I would just say turn the x's into like an a or something. So let's do, I got to switch over. Let's do 6 a squared plus 5a minus 7. And remember, that's supposed to equal 0. So if I put the values of a that they give me, the values of x that they give me in these choices, that should work. So if I do negative 5, and plus or minus, you can't do both, I don't think. So plus square root of 25 plus 168, and then that's all got to be over 12. We get 0, right? The a doesn't equal 0. That's some random number. But the equation, it's plugging that weird number in for a for us, and it's giving me 0. The only thing I'd want to do is double check. Let's switch it so that we have negative 5 here, or negative the square root. And I'm glad I did this because a lot of you might look at that negative 1.776 blah, 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 and think, oh, that's not 0. But notice it's function notation, or it's a scientific notation, and it's times 10 to the negative 15th. That's 0.00000015 times before we even get to the messy decimal. So it's very, very, very small. It's very, very, very close to 0. And this is where Desmos sometimes does break down. And somewhere in this process, what I think is happening is Desmos is rounding off a decimal that technically is going on forever, right? And so in the rounding, it's now plugging that rounded answer into the quadratic, getting another kind of unrounded answer. And so it's not quite registering it as a 0. It's registering as this very small thing because of a rounding choice it made somewhere in the process. If you're okay with that, then yeah, the Desmos, you'll be able to look at something like that and be like, oh yeah, the a is still right. It's just Desmos is glitching out a little bit, basically. But some of you are big fans of Desmos because it means, in your mind, that you don't have to think at all, that Desmos will do the thinking for you. That will get you in trouble. The SAT is good at writing situations where Desmos doesn't quite give you what you'd expect, and someone who's understanding what they're doing will be able to interpret that result and still get the question right. But someone who is just a slave to the calculator will not understand that this number here, negative 1.776356839 times 10 to the negative 15th, is 0. It's 0. It's 0. So, I like showing this stuff to you because you never know when it's going to matter. And hopefully if you encounter some of these little problems as you practice, it prepares you for in case something goes a little weird on the SAT itself. But quadratic formula also just solves this whole thing.